Good afternoon, everyone. Let's start with our last session at how we can interact with AWS for uploading our sensor data on AWS. So, in this session, we will be talking about various services as AWS is providing for IoT. Then we will be logging into AWS console. We'll explore possible services what we are having, and I'll let you know how to add a particular device on AWS IoT. We'll possibly try to add our DHT11 sensor for taking out temperature and humidity data. If we succeed in that, we can have a IoT deployed sensor on AWS. Why I said if we succeed in that, because in the morning I was having a security session, so I have tried out some variable settings on my machine, and a malware on my machine. So my machine is some kind of broken now, means the operating system is some kind of a broken, so it is not, sometime it is not supporting for any file, or it is giving a weird error. But we'll try to initiate it, but at least I'll try to show you a process how to upload it. And later on, when I format my system, then I'll make a video of it how to upload data on AWS, and then I'll post that video on our WhatsApp group. Okay, so let me share my screen. Better I'll save this as a PDF. Okay, so let's start with our AWS. So AWS is Amazon Web Service, as Amazon is a very leading and popular cloud service provider in industry, as we can see, as the Amazon's popularity is very high, that we are almost thinking about AWS every time when we think about cloud. But with the Amazon, there are several cloud services which are actually providing similar kind of a services. That is Azure. So Azure is a Microsoft's product. So it is a Microsoft based cloud platform. So basically, it is based with the Windows platform. Though you can create virtual machines which are running Linux or Unix operating systems on it, even some RTOS development boards also can be created, and there you can upload your valuations, or you can upload your data which is taken by the sensor. So taking on to a context of IoT only, Azure is also a good cloud where Azure can provide you a better solution in terms of Windows integration. So in every modern Windows, like Windows 10 or updated version of a Windows 10, we get a feature called Windows IoT. So what exactly a Windows IoT feature is? When we enable Windows IoT feature, it is giving us a platform where we can integrate our development board with Windows family. So this is very well supported with Raspberry Pi. I have not tried it out with Arduino yet, but definitely in nearby days I'll be trying with the Arduino. But I have tried it with Raspberry Pi, and it is very good supported to it. So basically, Windows system will be booting Raspberry OS, and we can directly upload our codes to a Raspberry, and whatever the instruments are connected to Raspberry, maybe sensors or the modules, that data we can fetch and directly publish on Azure cloud. So that Azure and Windows IoT integration is also possible. So Azure is in terms of Windows integration, it is a very good and most recommended feature what we can have, that is Windows IoT, and we can connect it with the Azure. So if you are thinking about to use a Windows IoT, then think about Azure as a cloud. But if you don't want to use Windows IoT, instead of that, you wanted to have your development board directly communicating with the cloud, then AWS, Citrix, and other cloud providers are there, which is best possible solution for us. Even Azure is also working on the same line. It is not always that you need to open up a Windows IoT service on the Windows 10 and then only you can connect with Azure. You can directly connect your device to the Azure as well. But as far as today's context is concerned, AWS is very popular, so that's why we are taking a session on the AWS. So, talking about the AWS IoT, it is a web service platform which collects and analyzes data from internet connected devices, as the uh, AWS official definition is suggesting. Now, when we say it is a service platform, it means what? The beauty of AWS is over the Azure or over any cloud service is AWS is providing all the services under a one roof. Means what? Though it is free for a 750 hours, so you can go and create your AWS account for a free, and after that, after a free period over, it is going to charge you. But until that, it is totally free, and all the services what AWS is offering, you can try it out. Even all the features of that service is enabled in the free trial as well. Only the thing is, they are having it on a very limited use, but it is okay if you wanted to try it out and you wanted to just feel of your services what exactly it is giving, and for a small application, it is good enough. So uh, advantage over AWS is when we are connecting our device to the AWS cloud, it will open other opportunities, like we can collect our device data and we can create a data set directly using S3 bucket or any Amazon database services or Amazon Elastic database service, EBS we called it as. So EBS or Amazon database service, Amazon Aurora is the database which Amazon have created with the synchronization of MySQL database, and it is quite good and stable with the unstructured data integration as well. So we can utilize those databases which are available, and we can create our data set onto it. And furthermore, for the analysis purpose, because why we required our data to be published on the cloud, to for two reasons. One is we can have a data visualization where we can see how much usage of that particular sensor is done, or a particular product what we have, or if we are talking about the agriculture, then in agriculture field, how many cubic meter uh, water you have sprinkle, or what kind of pesticides you are using. All these kind of a sensor data, if you wanted to collect and if you wanted to monitor everything, then we need to have a collection and analysis part done. That is the first reason. And another reason is, depending upon the functionality of product, we wanted to improve something into it, or we can take the data out and we can feed that data to a machine learning approach, where we can have a predictive analysis done, or we can have some kind of a prediction, or we can have some kind of a forecast, maybe a weather forecast. Weather forecast is also possible in this case. We can have a weather sensing sensors which can be deployed at agricultural site, and we can forecast what kind of a weather it will be in 2 days, 5 days, or ahead of a 1 month. And then a farmer can plan according to the season what needs to be what we done, and what kind of activity that farmer can do. But it is a very ambitious kind of a thinking when it is comes to Indian farmers, because unfortunately Indian farmers are not that technologically literate, or we can say that, because it is a very wrong if we say farmers are not literate or farmers are illiterate here in India, because farmers are having that kind of intelligence. They are having a basic education now. That is the changed what we observe nowadays. But these farmers are not that techno savvy. These farmers are not that technologically sound, where they can utilize all these kind of facilities what we are having. So that's why majority of the agricultural part is depending upon the traditional means of day-to-day activities. But there are some farmers which are taking advantage of edge computing or cloud computing or new technology for improving their fields and improving their production. Basically, because of the online industry, if you can see Amazon, then we are having big basket, we are having gophers. What they are doing, they are taking farmers land on a rent, and they are producing what they want on that. So to manage everything, these companies are employing with these kind of modern technology and modern services. So if we are having this kind of data which is collected and which is collected on the cloud, AWS cloud, then we can create a data set and we can feed it to our machine learning model, where it can do a predictive analysis, and depending upon the analysis it can predict what kind of a weather it will be and what kind of a crop needs to be taken on this weather and what kind of activity you need to do. Even if we are having a smart harvester working on the field, or we are having a smart sprinkler based on a drone which is sprinkling a pesticides or whatever the medicine you want to be on that crops, that can be controlled. So in that scenario, it is a very useful aspect to upload our data on cloud. So Amazon SageMaker is the service where we can create, deploy, and create a predictive analysis on the machine learning platform. So the SageMaker is again included in our free trial version, where we can create as much as model we can, but it is having a limitation on iteration cycle. It is having a limitation on feedings and all, but still we can create some methods. Even it is open for all types of connection. It can create a neural network, it can create a concurrent neural network, it can have a back propagation, forward feeding mechanism, everything what you want, that is available on the AWS. So I don't think so in a market or online market or a cloud market, these kind of services is provided by any other vendor. So AWS is very popular in this. Then, if we talk about further, then how exactly AWS is letting us connect our device on a IoT. Let's come back on a IoT part, as we are not into a machine learning session, but still, machine learning and IoT is very close, and it forms a very good duet, and it can form a very good application for you. That's why I'm always mentioning machine learning, and of course the security. So moving again back on the AWS IoT, then what kind of services Amazon is providing to get our data on the cloud, or sensor on the cloud, or thing to be connected on the cloud. So in the Amazon language, we are not calling that sensor as a sensor or module as a module. We are calling it as a thing, because that is the internet of thing. So Amazon is providing four kinds of stages. First is a AWS Management Console. So through Management Console, you can navigate to a service where you wanted to upload your things. Then there is a software development kits. If you wanted to create an application where you can control your device, like we did with the Adafruit IO, a similar kind of application you can create, or a dashboard where you can see and visualize your entire data and the cycles of a data, history, trend, graphs, every report. So all these kind of a thing, if you wanted to create and control your device, then you can utilize software development kits services. Then we are having rule engine feature. So here what exactly we are doing, so here we are creating user profiles, then we are creating device profile, we are creating policies, then we are creating access control. So we can ensure that the usability, security, and interportability is connected on the AWS. Again, I'm repeating, when we are creating a rules or creating a access control, then we are ensuring that usability, controllability means we can control the things, and interportability will be there for controlling your entire aspect, so that there we can create a rule engine. So that's why there is a rule engine feature. And then finally we are having a device registry. So after creating a device profile, or after creating a mesh profile on it, then we can register our device with AWS console, or we can say AWS cloud. So on that further, once we upload our code using a API what AWS is providing, so in our case there will not be a API. Instead of, there will be a ARN. So that is AWS resource networks address. So that is ARN address. So ARN address is like your URL, where we can see the data which is uploaded by our device. So there only, if we have created application using SDK, or the application, the customly made application which you have already hosted using other services of AWS, like AWS Lambda, or AWS EC2 instance, where we are creating a virtual machine. On that we can apply the hosting service, and on top of that we can host our service. But the reliable solution is you can use AWS Lambda or AWS App Maker. From that you can easily upload your code, or upload your application what you have developed offline. That you can upload it, or a website you can upload it. And later on you can utilize that ARN address to back propagate the data on your application, and we can see the beautiful dashboard, and all types of charts, or all types of communication on it. So that is what the device registry is. So exactly how the AWS IoT is working. So we are having different types of Amazon services there, and we can have a device which is a main part in this case. So right now, what device I'm having? I'm having a Node MCU as a middleware service provider. Oh no, it is not a middleware. It is again on a our device level only. Now, if you can relate this presentation with our IoT stack, then now you can relate AWS is what it is, a data aggregator. So here, this AWS is connecting with the device layer where the actual device is available, and from that device we are communicating over the cloud. Uh, just give me a minute, I'll be back. Yes, very sorry. I just need a water. That's why was gone for taken. Okay. So talking about the devices. So if you can relate this thing with our existing IoT architectural framework, so you can now imagine, or you can now relate it. We are having a device layer, and now the AWS is your actual data aggregator, where it is going to what we can say, it is going to attach your device with a cloud, and it is taking up the information what it requires, or giving out the information what is required. So there we can have that stack. So similarly on the AWS architecture, on the other hand we are having devices, and on the other hand we are having a different types of services to offer. So the device layer talks about every integration related with the devices. Maybe it can be on front of a sensor module, or we can have different types of devices which are getting connected, and that is connecting to a message broker. Now once the message broker is getting into a picture, then there are the protocols what we are talking about. So these are the IoT networking protocol that we already seen, MQTT, COAPs. So all these are what, these are the communication protocol which is working on a message broker part. So this message broker is actually connecting your soft layer, or we can say a communication layer, on a particular part where it is communicating on the front. And then we are having this device shadow. So this device shadow is doing what? Device shadow is a kind of a structure what we have created on a AWS. So this AWS cloud is providing us a room where we can create a device and we can register a device, right? So while registering that device, what we are doing is we are giving us some properties of it. So in a while we'll see how to create a AWS device, or we can enroll that device on AWS services. So that is what the device shadow is. So message broker is always talking with the device shadow. Now why this is a device shadow? Literally by a name, we actually making a what we can say a name it exactly as we are having a device which is physically connected on our device layer, and we are having a device which is virtually created on the AWS. That's why it is a shadow of your actual device. So that's why it's mentioned as a device shadow. So what message broker is doing? Message broker is taking a device information, or whatever the data is collected by sensor from the device layer itself, and it is again forwarding it to the device shadow, means the other virtual device on the device shadow. So that device shadow is communicating with the sensor now, and then that there is a rule engine. Now what rule engine will be do? Rule engine will be defining the authority, defining the what we can say uh, how exactly a user can communicate with the device, or what type of a communication can be happened, or what kind of access control that user is having, what kind of display that needs to be done. So all these kind of rules or the functionalities we can set over the rule engine. So finally all these three layers, basically if you can see the layers in the green boxes, so all these three layers are on AWS cloud. And there is a feature of AWS, once we are creating any kind of a cloud environment, there we can have a VPC. So that VPC is virtual private cloud. So in every VPC we are having a security group. So if you are remembering, there is a IoT architectural stack where we were talking about IAM, that is in identity and access manager, or the management. So this type of access control is taken care by the security group. So it is a by default architecture what AWS is having. So once you are creating a AWS account, automatically AWS services will enroll your profile into a VPC, and each VPC is having some basic functionalities or features enabled. Basic functionalities and features which will include network, security, and communication. Now, when I say network and communication, these are two different services what Amazon is providing. Once we say a network service, it means what? On the AWS cloud or on the VPC, the virtual private cloud, what we are having, because there are two types of cloud we can create, a private cloud and a public cloud. Only the difference in these two is private cloud is managed by a single person or a authority, and public cloud means what? It is managed by a single person or authority, but it is visible to entire function entire world. Or if it is connected to a website, then anyone on the internet can utilize the services out of it. So that what the VPC is. So if we wanted to have some kind of a network operation, then we need to have an internal and public IP address. So the networking layer or the networking service ensures that we will have a IP address, will have a networking stack running on maybe a TCP stack or UDP stack or ICMP stack. Now other hand, on a communication part, it will take care about the communication protocols what we are seeing. So uh, on the front, when we talk about communication protocol or the communication service, then on the communication service, we can have a different types of a communication protocol to enable our network services. So to talk on a network service, like we need to have SSL, we need to have HTTP, we need to have FTP, we need to have other kinds of a protocol which actually going to talk on the network, because network layer is what it is mimicking your physical network, where the wires are getting connected, where the routers switches are getting connected, and you are getting an infrastructure. So network service only talks about infrastructure. Communication service talks about how the infrastructure will try to communicate with each and every network device. So on this entirely, if you can see, there is a security group which is getting configured. Now the security group is actually responsible for every type of a communication what we are doing on the cloud. So this security group consists of different elements. First one is access control, another one is device control, third one is location control, fourth is identity control, fifth is authorization. So kind of there are uh, various services what we can actually configure. So the security group is already attached to each and every profile what we are getting. So on AWS IoT cloud also, we are getting all the instances, like just I mentioned, all these instances will talk. So if you can see on the green, there is a message broker using protocols or the IoT communication protocol to have a communication between device, actual device, and with the device shadow, which is the virtual device which we will be creating. So that will be our virtual device what we are talking about. Then there will be a rule engine. Now all the communication which is flowing, that needs to be accessed. So that accessed permission, or that access permission, or that rule of engagement will be done using rule engine. So this rule engine is mainly responsible for communicating on a different part of the authentication cycle. Maybe we will be having our own application which is going to deploy on a web, and that web application will going to talk on Amazon IoT cloud, where it can fetch some data from cloud, and it will display the data on our application. That is the one scenario what we can see. Another scenario can be our device is directly connected using message broker and device shadow to a AWS IoT cloud, and there we have created an application which is hosted on AWS itself, and then that uh, application is getting backed with the data what is collected by this device. Or maybe there are some different services what is Amazon is providing, which are configured for utilizing this information what we are fetching. The first service can be Amazon DynamoDB. So it is not actually a DynamoDB, it is just a Amazon database service, but I've purposefully mentioned one database, that is DynamoDB. So Dynamo database is again supported on Amazon, as Amazon is that popular, as we can have almost all paid and open source or free database which are used in industry, and which is open source again. If we can see, some open source databases are emerging, that everything is available on Amazon. So whatever the database service you wanted to utilize, or you wanted to create a data set out of the data what we are collecting, maybe that data can be in any form. The data can be in a text, data can be in a graph, data can be in a graphics, data can be in a photo, data can be in audio, data can be in video, audio and video both. Now you will say why you are using these three different words. Just say audio and video. No, once we talk about audio, that is only audio, and there will be a different extension of that kind of a data, maybe a .mp3, maybe .wav, maybe .ex. So there are different types of maybe .flv. There are different types of audio formats which are available. Similarly, with the video type, in a video data there will be no audio clip inserted. So it is like our perception, like when we see let's play a video, it means what we are considering that video and audio. No, but technically if we see video, if we see a video feed, then it only consists of frames, and these frames can be packed into a different extension again. And here this is the most complicated data, because on audio is not that complicated, which is as compared to the video, because audio consists of the codes which we can easily check and recheck or redo. That is what the codes are, or we can call it as a G code. Those are the instructions. Generally G codes are used for 3D printing and for providing a instrumentation or instrumental instruction for different types of a maneuver what that instrument can do, maybe a rover, robot, or robotic arm, or any kind of RTOS applications. So again, on the audio there will be a frequency and all, but these can be managed easily. But video is a much complicated, because we are having frames that needs to be played in a certain what we can say in a certain speed and in a certain manner by a sequence what it is captured. uh, Secondly, to convert these frames or into a playable video, that we require a playback, and there we need to have a encoding and decoding, because it needs to encode first, then it can have a package, and then it needs to be decoded in order to display it on a video player. So the video player is having decoders inside. So sometime if you are having a .vaw file or VAMW file, VAM file, then it says your video player, maybe a VLC or any other video player or a Microsoft video player, will say codec mismatch. So what is a codec? Codec is the decoder and encoder for that specific file format. So once you give that instruction, then automatically it encodes. And again, there is more complex file, that is audio and video, because it is a merger of both and it is having its unique features. So that's why these three things are different. So you can get all these kind of a data and you can store it onto your database. Now these kind of a data can be created by different kinds of a sensor. You can have ultrasonic sensor which can create a wavelength of a data. You can have a DHT sensor which can create a text documented data. You can have a video camera where it can get video data. You can have a microphone, you can create audio kind of a data, and all these kind of a data can be uploaded. Then we are having Amazon Kinesis service for a data visualization. So there are different types of a data visualization services which are available on the market. But the Amazon Kinesis is a very best tool in onto a Amazon cloud, because it sustains for a different types of a logical data integration, and it can have a perfect data visualization in the terms of a quality. Then we can have AWS Lambda for creating and hosting our web application. So the basically a Lambda service is consist with the different types of other service like PHP and other all required service to create a web application. So I'll be not getting very deep in this, but we can observe that the AWS Lambda service is performing well. Then we are having Amazon S3. S3 is simple storage service. So instead of having a DynamoDB, we can have S3 to collect some data and we can optimize it. Then we are having Amazon SNS, that is Amazon secure network service. Now what the or sorry simple network service, not the secured, as I'm an information security guy. So whenever I see IS, that means information security, and whenever I see S, it is a security. Okay, so Amazon SNS is a simple network service which includes with the messaging services. So if you wanted to alert something, like in our scenario, we are collecting a temperature and humidity right now from the DHT11 sensor. So from temperature and humidity, we can create a minimum ratio of the temperature and maximum of a temperature, and depending upon that, whatever the temperature is recorded on a periodic way, we can send SMS or alerts to the what we can say to our recipient for showing that information. So there we can utilize Amazon SNS service. According to the same, that is for the SMS, for the email and other push notification, digital notification, there are SQS service, which is a queuing service of Amazon, where it can push messages on a digital media. So all these services are very essential services in order to create application which is taking an input from sensor and giving us some kind sort of a what we can say some sort of a output, and together all the structure we can call it as a IoT application over a cloud or over a Amazon. So talking about the same, let's talk about some features what AWS IoT is providing. So starting from the first, if we talk about the authentication and authorization, as AWS is packed with pretty much every single security layer, so it is having a fantastic authentication and authorization scheme. But as a security auditor, I will not suggest to use word it is highly secured, but yes, it is having a good kind of a security, it is having a good degree of a security. And once a security person says that it is having a good security, it means a lot for a developer, because usually we auditor never use such kind of a word for a security as it is a good kind of security. We generally says that okay, security is enough for this deployment, or it required some, it is okay but it required some modification. So usually we do not tend to use word good, because it says that it is having a very good implementation of all the security policies, then it is having a good authentication mechanism, two-factor authentication, three-factor authentication, and whatever the authentication scheme we are having, it is having a good encryption, good decryption, good encapsulation methodology, then it is having a good transmission level security, distributed security. So all these kind of a security environment what we are having, so Amazon is pretty good in that. And there are very less chances that your application which is hosted on Amazon will get hacked because of the Amazon services vulnerability, not because of your application's vulnerability. If there is a vulnerability in your application, Amazon will not responsible or not take a responsibility for that. But yes, of course, if the Amazon is providing a core services and some vulnerabilities are there in core service, definitely they will take the responsibility. So the authentication authorization is very good in the case of AWS IoT. Then we can have a registry. Now this is what where we register our device. We need to create a device shadow. That is the second feature, that is a device shadow, where we are instructing our AWS to create an infrastructure or to create what we can say a room for my device where it can host some services. So that is what the device shadow is. Then we are having rule engine that we already discussed about. Then the AWS IoT device SDK. Now that was the software SDK, and now this is the device SDK. Now here we can control our device, or we can create a control statements for our device. So that is what the AWS IoT device SDK is. Then we can have a device gateway where we can create our device and we can deploy it. And then we are having message broker. Yes, so the part is now for a working. Let's see some working demonstration how we can register our service on a Amazon IoT. So for this, we'll of course require AWS account. So here I'm having it. Yeah. So once we log in into Amazon, we'll see this kind of a dashboard. You can create your own account that is for a free, and once you are in AWS, this is what the console is, or this is what the management dashboard is. So here these are the different services what Amazon is providing, and all these services are free for use for up to the limit 750 hours a year. So for a year it is free up to 750 hours. So here we are having a very good categorization of the services, like the compute service, storage service, database service. Here we can have a database service, migration, network, customer enabling, blockchain, satellite service, quantum technologies. Then we are having here as IoT, where it is. We are having robotics. We are having delivery tools, media services, analytics, security, and here it is Internet of Things. So under Internet of Things, there are different types of applications, or we can say sub services that Amazon is providing. First one is IoT Core. Now, what is a IoT Core? IoT Core talks about a basic integration. Now, the same we are doing today. So IoT Core is taking your direct device and connecting it onto a cloud and reading a data. Then we can have a free RTOS. We can have IoT one click. So this one click is what already your device is enabled, so you can directly start uploading your data. Then we can have a IoT analytics, device defender. So the device defender is a kind of a security solution what AWS IoT is providing for protecting our IoT devices from getting hacked or DDoS. Then we are having device management, like the manager SDK we just discussed about. Then we can have events, greengrass, sitewise, and thing graph. So today what we'll do is we'll explore its basic functionality, that is IoT core. So once we click on the IoT core, now the AWS service is a very good, having a very good documentation and having a very good how-to guide. So once you click on any service, there will be a self-learning kit which is already there. So here also you can get a self-learning kit. So if you can see here, it can talk about how to connect and manage devices, process and act upon your device data, read and set device state at any time. So these are the things what you can learn. You can click on the learn more, and you can actually go in that documentation. Like if I click on the learn more, then it can give me a very good documentation. Device communication protocol. So what is a device communication protocol we can have, which supported by Amazon? It can support MQTT over WebSocket. It can support MQTT over WebSocket with the different authentication scheme. It can support for MQTT for publishing X509 client certificate, having a different sections here, support and access ports, LAN, MQTT, HTTP, HTTPS, publishing, writing, rewriting. So all the information related with device communication is here. Even if you can click on what is AWS IoT, you can get a lot of good information here talking about how AWS is helping IoT for getting onto a edge as well as distributed cloud, because AWS provides both the functionality, edge and distributed services. So that's what the AWS is known for, as it is giving always a more than what is subscribed for. So that is what the user says about AWS. So yes, AWS is actually on that scenario only. It is providing a very good service than what actually a client is expecting. So here is a good guide, and this is for the developer. So if you are a AWS developer or IoT developer, not the AWS IoT developer, this is the best suitable guide for you. So take some time and just go through with the guide. You can learn a lot of things about AWS IoT. Even I heard about that AWS is creating a IoT simulation also. I don't know. I have not found any kind of a link for that, but maybe it is a rumor. But still, some kind of a thing AWS is already developing. And AWS is pretty much good in rover technologies, as AWS is thinking about, or the Amazon is thinking about, to have a flight delivery, air deliveries. So for that, drone delivery options they have already developed, and they are into R&D. But unfortunately in India, they don't have a permission to deliver your packages through drones, but in some countries they are doing it, and they're receiving a good responses. Okay, so back on our main topic, let's see how we can create a device clone or a device manager to have our DHT11 on board on a AWS. So for this, we need to click on manage. So here you can have an option like thing type, thing groups, billing groups, jobs, and tunnels. So we need to navigate to things. From manage, you need to navigate to things. So things are what? Things are the devices. So here I have already created a one thing, that is DHT11. Let's create another one. I'll click on create. Now here it is asking me what type of IoT device you wanted to create. Now here I wanted to register one device only. So I'll be clicking on create a single thing, or otherwise if you're having a device bed where you are having 4 or 5 sensors attached to it, then you can have a bulk registration. But here I'll take it with the first one. So here you need to give a name. So I'll type temp underscore DHT11, temperature DHT11. Then here you need not to select anything, apply a type of the thing. So if the thing's type is there, if I type temperature, but it is not actually there, so I can create a type, but here it is not required. It is just extra information. So here I can click on next. The attribute key and value, it is totally optional, as if you are having a policy, setted policy, then you can create this. Otherwise just click on next. Now it will ask you to download and create and download a certificate. Now what is a certificate? This is a digital certificate. It is verifying the authenticity and the originality of your thing. So means what? It always recommended by the Amazon to have your certificate with you. So if similar kind of application or similar kind of a thing is already uploaded on Amazon, then it will not have any data mismatch, or the right ASN or the ARN will be allotted to your device. So, and of course for the different types of security purposes. So just click on create certificate, then it will create a certificate. We need to download 4 certificates over here. First one is the thing certificate, the validation for our device. So that is what the first certificate is. Just click on the download. It will be in a PM key. Then we can have public and private keys to decrypt it. So we'll just have it. Okay. Then we need to click on download here, as it requires a Amazon root certificate to verify. So here if you click on the Amazon root CA1, even if you are having a VeriSign endpoint security solution with you, you can download a RSA 2048-bit key, but here we recommend that you download Amazon Trust Services, which is preferred, and which is preferred by Amazon as well, because it is very easy to integrate. Just right click on this and click on save link as, and download it. I have already downloaded, so it will ask me to replace. So I'm replacing it. Sorry. So I've done here. Just close these all tabs so I'll not get confused. Now once you downloaded everything, just click on activate. It will activate our service and certificate. It will show certificate created, and my certificate is activated. Now what we need to do is we need to get into a secure here, the option, and we need to create a policy, because here it is option to attach a policy. A policy is means what? The rules what we will be going to create. So that policy will be created in secure underscore policy. So here I've created a my policy. I'll create again a new policy for my new device. I type DHT11, sorry, DHT11 policy. And here at the action, what we need to do is we need to type IoT. So it is saying that what type of action this policy will do. This policy will do publishing of your information, subscribing to a device, connecting to a device, receive data from device, update a thing shadow, means what, updating a virtual device what we are going to create, and get thing shadow means get the data from the shadow or from the virtual device and pass on to the actual device sensor, or you can delete it. So I need all the services or all the actions. So that's why we can select the first option, IoT dot, which is asset trick mark. And here it is the ARN, which is required for our application. Once we are coding it, we need to put it instead of API. So here the effect is what, all the services will be allowed. Don't click on deny, otherwise it will not accept any kind of a service. And if you wanted to add something else, then you can create on add statement, and you can have another action and you can deny it or allow it according to your user policy. Now you can click on create. Now this DHT11 policy is created. Now we need to get back on the things here. Then we need to click on temp DHT11. These are the details. This is the ARN what is created. On the security, we can see our certificate which is created. We just need to click on the certificate. Here it is. This is the certificate what is activated for my thing. And here is the policy. The policy what we have just created, we need to add it. So for adding that policy, to click on action, click the attach policy, and select the policy what we just created. So this is the DHT11 policy we created. We're attaching it. Even the other policy if you are having, that also you can attach to it. So this policy is already attached to my AWS IoT device. Now I'll go to thing. Now this is the thing what I have selected. Now again back, I'll come on the things. Now I can go back to the thing again, and here I'll go to the shadow. If you can see that this is a classic shadow. Now what is a classic shadow? Classic shadow is the default service. Well, it is creating a device shadow, so it means that my virtual device is already created. Now here if I can click on activity, so there is no listening for a 1 minute. Means what, now whatever the data we will be having, that data will be coming on to this activity tab. So here it is MQTT client. If I click on the MQTT client, then it will ask me to publish data for subscribing a particular MQTT server. But here I will be not doing it. Instead of that, what I can do is I'll be copying this ARN, which is interact, which is there in the interact service, and then we can click on the connect to the service. So here is the option to connect on the service. But first we need to do some modification in our sensor code. So that's why we are taking up the HTTP API endpoint. Then we'll go to the code. Here I'm having a code. No, this is a servo code. Okay, so this one is the code. So here the quick changes. What we need to do is we actually need to change something. So here we need to add one tool called sketch data upload, because I'm using a node MCU. So node MCU needs to have a sketch inside its file system. So for uploading it, we need to add this service. So that service I have already added, and then I'll be adding up my AWS endpoint address what I have just copied, and my SSID and my password. So here is the DHT11 temperature code, and I need to specify which port I have used for DHT pin to operate. So here I am using D1. I'm not using D6. It is a D1. Again, I'll save it. I'll check for the possible changes. It is not having any. Now here we need to upload our keys as well. So here if you can see SSL, which is supporting all SSL ciphers. So let's run this code first, try it out whether there are any errors. Yes, there is an error called pub subclient.eht. This is a new error what I am having. So I just check it out. Any of the library is missing or what? Yes, so there is a library which is missing. So what I will do is I'll just copy this library and add this into my Arduino IDE by managing the libraries. If this is the best way to add the library, if we are not able to find out any library, then we can directly download it from here from the GitHub. I can go to manage libraries. So there are so many libraries for MQTT. So here it is a client which are required. I'll just install it. Okay. And then I'll try to re-upload the code. Now if you can see pub client.h is accepted. It's now compiling my further sketch. As this is done, it's supposed to upload all the information on our AWS endpoint. Even if we try to browse the endpoint here, what we have uploaded, we can see something. This is trying to connect with the endpoint, and here our data is uploaded. I'll check with the serial monitor. Now it is showing that failed to open cert file, private key is not loaded, and it is trying to connect with RX100. So maybe it will fail as the private file is not uploaded. And here also it will not show anything. And on the device here is listening, but it is not getting anything as file is not uploaded. See, it failed. I'll just borrow a little help from internet how to do it, because recently Amazon have changed their structure to connect with devices, and to be very honest, uh, 2 or 3 months I have not connected any device with the AWS. That's why I lost touch with it. and they are having a very new features like they need to download the certificate, then they need to that certificate needs to be uploaded on the device, and I'm actually lost in that. Let's see how we can do it. Just borrow a little help from this guy I was referring to. It's showing that I need to. Okay, okay, okay. There is a private key what we have just uploaded that we need to convert into a DER file. Amazon root I'll be converting. Here it is. I'll just copy this root to the folder where from where I'm uploading my sketch. Then I need to upload for certificate SRT. Again, need to convert it. It will be in same folder, and then it shows what. It is showing assert not uploaded. I'll just try with the private key. Let's try it again. No, it is not getting it. Maybe I'm doing something wrong with that, but definitely I'll figure it out how to connect with this. Or what we'll do is we'll just try to connect it with the MQTT client. But the client is already configured, but it is not getting a data on it. Yes, definitely I'll get back to you all once I've resolved this issue. Why it is showing, though I have given a certificate, it is showing some error onto it. But this is the procedure where you can register your device on AWS IoT and can perform various operations. So by this we can create our application even, and for the same way we are seeing our thing here, and we are seeing the activity and whatever the message we can see over here. Similar, Similarly, this can be uploaded on our application or on a third party application using ARN or using API what Amazon is providing, and we can fetch that data from cloud to the another cloud. So that kind of a situation we can create, and we can have a multi-layered cloud architecture and multi-layered cloud infrastructure to support our IoT, and that is the way the massive IoT is working. So yes, So this is all from my end. We are open for question and answers. If you all are having any question, anything to add in this, or any suggestion for me, please, your suggestions are also welcome. I'll try to incorporate in my next session, and any improvement in my side, I'll appreciate if you can give your feedback on that. So thank you, and we are open for question and answers. Yes. Any question, any doubt, anything to add in this, participants? So I think there are no questions or anything. So I'm very thank you to all participants for listening me and giving me a good response. So in future also, if you're having any question, any doubt, or anything where you want my help, or if you want FDP or SCTP or any kind of a training you wanted to conduct for your faculty mates or for students, here is my contact details. You can reach me on my phone 7620953455, or you can have WhatsApp to 703001299, or you can reach me on my email, that's amaytambe@gmail.com. So not only with the IoT, if you are having a requirement in any other technology like machine learning, big data, or security, cyber security, information security, 3D printing, or any other technology, do let us know. We'll definitely try to help you in all the manner. So thank you very much, and thank you all for listening me. Thank you organizers for organizing this beautiful FDP. Thank you Kulkarni sir for inviting me and giving me this opportunity to interacting with such a fantastic audience and participants. Thank you very much.